So this is something that a lot of time people struggle with, especially when you're working with particulate systems like, particulate matrix composites or any voidal systems where you've got particles that are protruding on the outside of the main domain that you're working with. And especially if you're interested in allowing those particles to remain unmerged. So, and the question is, how do you trim off all those individual particles so that you end up with a domain where all the particles are encompassed within a domain? And so that's what I'm going to be showing in this video. So if you're interested in this, sit back and relax as we go into this video. So as we start this, I want to sketch the problem so that you can understand what we're trying to deal with. So if this was to be a 2D case, so this is sort of the kind of problem you get. So you got a domain. Normally you will have particles that are nicely located inside the domain, but there may be cases where you've got particles on the corners like that. And so clearly what you want to do is to be able to trim off those corners by just kind of erasing them and deleting them. So I have everything located internally within the domain. And under these instances, obviously, it makes sense if you're doing it in 2D and those particles are meshed as one entity, you can nicely trim them off. But I want to do this in 3D. So let's consider what the 3D situation is. So this is 2D. So in 3D, you basically would have a domain that looks like this. And let's imagine that you've got a particle on the corner. So let's say we've got a particle that is probably protruding out like this. Okay, so let's say there's a spherical particle that is protruding out like that. So how do you go about trimming off this fiber? So you could also have a particle that is probably at the top like this, protruding out. And then you may even have a particle at this corner that is also protruding out. And in all these cases, you don't want them because they should really be located internally within the system, like in all these cases. And so we need to have a way to be able to deal with it. And that's what I want to do with this. And so how are you going to go about doing this? So the principle for this 2D case will essentially involve you having a domain inside. So you create a domain inside that you're interested in keeping, and then all around it, you provide another bigger domain that you're going to then use to extrude cut. So if you use this to extrude cut, that will be the solution. And actually, if you want to learn more about this 2D system, watch this video, which is a video I have made that illustrates this problem. But we're not focusing on the 2D case, we're focusing on the 3D case, but the same principle will apply. So clearly what we need to do with the 3D cases is a similar situation where we isolate the particle that we want, and then we extrude cut it. So let's say in this instance, if I'm interested in a spherical particle like that, so if that's my spherical particle, so that spherical particle, I need to locate where it is in space. So if I can find out where it is in space and find out that, okay, maybe somewhere around here, that's where we will need to extrude cut the system. If we watch the system from this angle, so what we will see on the side view here would be a system that looks like this. So there will be the particle that is being seen on the corner. So that's clearly what we want. So what we then need to do is to find a way of isolating this system again, and then we'll find a bigger system around it that we're going to use to extrude cut, just like we did before, so that it trims off what we're looking at. And so how do we go ahead doing this? So within ABAQUS, you can first create using the extrude cut option. So we're going to use the extrude cut option, and that means we need to define a plane, a datum plane. So I'm going to call this a datum plane. So we want this datum plane, and then also we need to also define a vertical axis on the right hand side, so that this will then be what we are going to use to project onto that surface that will allow us to extrude cut the system. So that's the philosophy, that's the principle. But it makes sense if we can actually illustrate this within a final element scheme. And that's what we're going to do next. If this is the kind of content that you like, please do subscribe to this channel if you have not already done so that when content like this are made, you'll be the first to see it. I also would encourage you to share, like, and leave me a comment in the comment section of this video of maybe ideas of videos you would like me to make or anything related to the video that interests you. Okay, so here we are in ABAQUS. So this is the problem that we have. So basically, I've got this cubic domain, and there are all these particles that are kind of located at the corners around them, all the way around. So we don't want these particles, and we want to be able to trim them. And so this is in the assembly module, and each of them has individual component. They are all isolated. So if I just hide the cuboid, so if I hide the cuboid, then you can see where the particles are all in the places where they are located. And so we need to trim them individually. So if we go to the parts module, so let's just start with, let's say, the box. Okay, so this is the box. So first thing I will always do is to look at what's going on in the assembly module. Okay, and then I'll basically show that. So where is the box located? So I'll go back to the reference. So it's located on this face. So if we want to extrude-cut the system, so what we then need is to work with this window, so that if we can isolate this window, then we can cut through that domain to extrude-cut it. And so the first thing we need to do is to identify the corners that make up the system. So I'm going to basically create datum points for all the corners. So we're going to use this query button, and I basically want to find the point. So for each of these points, controlling shift, so I can select all the corners by pressing down shift and pick up all these 5 corners or six corners. So we find them and then click done. So what this will do, if we look at it gives us the coordinate positions, and of course with that we can then find out the locations of these coordinate positions. Okay, so this is sort of the domain that we are looking at. So basically we've got all the particles and all the coordinate positions located exactly in the way they should be here, and we need to note what all these locations would be, because we're going to use them as guidelines to create datum planes for the problem across in the end. So that's the first thing. So remember, the system that the first case we want is we're going to focus only on this first case, because with that system we can then extrude cut so that we can cut through with the block case. And so what we need to then do with this particular first instance is to create a datum plane. So if we can create a datum plane here, and that datum plane, we need 3 points to create it. So we use this point that is linked to there, and we use this point that is linked to there, and we use that point that is linked to that. So that gives us a datum plane that is created based on 3 coordinate points. And then finally we also need to use this one as well to create a vertical line. So this will be our vertical line that we're going to use. So this will be the datum axis, and then this bit will be the datum plane. So we're going to use all that as part of creating the solution. So let's show how you can do this inside of ABAQUS. So first thing is that we need to find all those datum points. So if we come over to the axis here, so it says here create datum coordinates. So we'll just create based on the numbers that we already have here. So the first of them would be 60, 0, and 60. So you can see that creates a datum point there. So we can go ahead and do it for all of the cases involved. And that's the last one. So we've got all of them. Now we're looking at using these 2 coordinate points. So in order to do this for the box module, I've written a tiny Python script that we can use to make this process quicker. So again, we're working with a box, and this is the part name. So the module name, we're going to put it here. And then for the first instance, we're going to work with, so here, this is a little Python script that helps create those coordinate points automatically for us, and that's what we see here. So I just need to change the part name and the module name are there. So I'll click through A to copy. While I'm in the part module, I can just go onto the kernel window and paste that command. So what it will do now is that it will create all those coordinate points for me in the way it should be. So if I go to the view window, and then I could actually ask the system to show datum labels as well, so that we can see exactly what's happening. What we now need is those 2 points to create these coordinates on the YZ plane. So I'm going to first create the datum. So we use this option. If I click and hold, so there's this third option here which says create datum by 3 points. So I'll click there, I'll click here, and I'll click there. So that creates the datum. So you can see this is datum plane for only on the system. Now I want to also create a vertical axis. So I press and hold here, and then find this option which say create a datum axis based on 2 points. So I'm going to use this point and that point. So that forms a vertical axis, and this is my datum plane. So that when I want to use the extrude cut, which is a powerful tool for making this cut, then I'll go here and say, okay, I'm clicking on that, and this is my vertical axis. So it now shows us the problem in the way it should be. But if you think about what we're trying to do here, so we are interested in this system, we're interested in this face. So now when the system turns out, so if we just check what this will look like when you go onto the right side, so this is sort of what we are looking at. So you've got the particle that we're interested in protruding out here. So essentially on this plane of sketch, so if you look at the axis here, so this will be the x-axis and this will be the y-axis. And so we need to get the system looking in the x and y-axis. And if we do that, so this is the x and y-axis, so the particle is looking correctly in the way it needs to look. So all we then need to do is to find which part we want to keep. So according to this figure, we want to keep the inside part and then leave out the outer part. So using the power of extrude-cut, all we need to then do is to say, okay, this is a part that I want to keep, and then every other thing outside it, I don't want to keep it, so that I can then extrude-cut the system as it is shown here, so that the inside bit will be what is left. So we have the inside bit looking correct. So in this case, we want to keep the inside and leave out the outside. So I'm going to click here and then, okay, so I want to keep everything on the inside, and then on the outside, I don't want, so basically it's going to trim off all that bit. And once we've done that, we can then click done. So it gets us into this window. I say, okay, I want you to cut through. You need to check, make sure that it's pointing in the right direction. If we do that, it's trimmed it off. So that if we then go back to the assembly module, you could see it's nicely trimmed off and we've got the fiber looking exactly as it should be. Now, let's think about the sphere. So we need this axis, which is the YZ axis. So for us to be able to work on the sphere, what we will be interested in here would be this plane. So we're going to cut through using this plane, and so that means the 3 points that will be relevant for our study will be this point, and that point. So those 3 points will be the point, and those are the points that are on the Y, the Z and Y axis. So we're going to work with that. So let's go back and open up the spherical system. So this is the spherical module, so we then need to create all the reference particles. Since I already have the particles there, all I need to put here is to change the path name to a sphere and then select all, copy, and then I'll paste it in this kernel window, and it's created all the particles for us. So clearly what we're looking for is to use this right side of it. So I'm going to use the same, creating a datum by 3 points. So I'll select, select, and select. So that gives us the plane that we're going to use. And of course on the right hand side, we want to also have the vertical axis. So we've got the 2 vertical axes, and then we can then extrude-cut by clicking on that, select the plane, select the vertical axis, and so we have a system like that. But then if you go back to the problem that we're trying to solve, so if you look at it from a different view, what we're going to have here would be particle system, that's the matrix, and that's the sphere. So this will be the Z axis and this will be the Y axis. Again, what we want is to keep the inside and then extrude-cut the outside, so that in the end, we're going to have a system that looks like this. So we'll keep the inside, basically, and then everything on the outside, we're going to cut it off. So, but the key is that we need to keep the system so that it will be in the YZ axis. So how would the YZ axis be? So you go onto it and look at the YZ. So this is the YZ axis. So YZ axis, so we've got the particle. So that means we're going to keep what is on the inside, and on this other side, we're going to remove that. So how do we do that? So again, you click this button. So everything on the inside will keep. So everything on the outside will leave out. So what is inside the first box is what we want to keep, and the second box is what we don't want. So that means this inside will be kept, and then I could now click done. So you could see, however, it's pointing in the wrong direction, so we need to flip it around so that when we do that, it cuts out properly. So if we're going back to the assembly module, you could see now the sphere is also extrude-cut properly. So let's do for the one at the top here. So which is the ellipse. So there are 2 types of ellipse. So we've got the ellipse and the ellipse horizontal. So the horizontal ellipse is the one that is underneath. The vertical ellipse is the one that is here. So I'll just leave it like this. So I'll go into the ellipse module. Now go back to here and just change the path name to ellipse. Select all, copy, and then paste it in this window. So that will help us create all those reference particles that we want. But then let's think about the problem that we're trying to solve. Okay, so what we are interested now is the one at the top. So how are we going to do this? So there are different ways we can think about this problem. But let me just say, okay, if I decide to use the same window, this particular part, as a way to cut through. So what is that axis? So this is the axis of the Y, the Z and the Y axis. So that in the end, we're going to extrude-cut through this direction, and then everything, it will end up cutting what is on the top. So that's the key of what we want to do. So if we go back in here, so we've got a system. So I'm going to use the YZ plane, and we're going to do this by clicking on that. So that creates the YZ plane. And then I need the vertical axis, which I click on that. I select those 2. That gives me the vertical axis. And then I can extrude-cut based on that plane and based on the vertical axis. So again, if you go back and think of what we are looking at. So for this system, now in the plane in which it is sketched, which is the vertical plane, what we are looking for is a Y and a Z plane. So we come back here and look at the YZ axis. Okay, So that's the YZ axis, and it's looking correct in the way it should be, Y and Z here. So what we want is to keep what is below and delete what is on top. So how do we do that? So basically we'll zoom in. What is below is what we want to keep. So the first box is what we keep, and the second box is what we don't want to keep. So basically the space outside is the extrude-cut, and then we click done. So again, it's pointing in the wrong direction, so we flip it around and then click OK. So you can see the particle is below, and so if you go to the assembly module, you could see it's also gone down as it's supposed to be. So we could go ahead and do the same for the remaining particles. So I've got other ones, so let's quickly do that. So if I now move on to the cylinder, and then I just come here and select the cylinder, change that to cylinder. So copy that, come back here and paste it. So what it will do is that it will create the positions for the cylinder. So if we rotate it to see where the cylinder is, so basically this is a cylinder. So it means that for us to get the cylinder to be extrude-cut, we need to use this front plane. And this front plane is the plane of Y and Z. So if we go back to the part module, so we need the Y and Z plane, and then basically we create the, and you need to create this datum plane because we're working in different parts. So, and then we need to create the vertical axis. So we start from there and there. So that's a vertical axis, and then we can extrude-cut. Basically you select that plane and select the vertical axis. So it comes into this plane that we want. So we need this to be in a YZ axis form, which is this format. So again, what is inside we keep, what is outside we leave. So we use this. So I'm going to create what is inside we keep, and then what is outside we're going to leave it out, and then done. Again, it's pointing in the wrong direction. You flip it around and you click OK. So that way, if we go to the assembly module, you can see that we have also extrude-cut the cylinder. So let's think about the cone. So it's basically a conical arrangement that is here. And so what will be the axis that we are going to use? So it will be the Y and the X axis, the Y and the X axis, so that when we extrude-cut through, it will trim off this. So let's go back to the script here and then say, okay, I want the cone, select all, and then paste it in this window, which will then create all those reference points. Again, this Python script will be available for you in the description section of this video, so please get hold of it if you need it. So we want the Y and the X. So we create this, and this represents our plane. And then the right hand side of it will be 4 and 3 datum points. And so that we can then say, okay, this is the axis I'm using, and this is a point. Okay, so but we want it in the other way around, so that you got Y and X, Y and X. So that means, again, what is inside we keep and what's outside we leave out. So I'm just going to create the box that represents what is inside, and then the bigger box what is outside, and then we can then go ahead, and again the direction is wrong, so I'll switch it around and click OK. Alright, so let's study that. Okay, so again, it has done as we expect. Everything looks all right. So the last one is the ellipse, the horizontal ellipse. So we go back here and say, okay, horizontal ellipse. So we'll give the part name called ellipse hole. Select all, copy, and then if you come into the horizontal ellipse, so I'll go and paste that here to again create the system that we want. Now, if you study the system again, if you go back to the assembly module, so horizontal ellipse, how best are we going to trim the horizontal ellipse? Okay, the YX plane that we used before will also work again. So we create this, that, and that to create the plane, and then with the vertical axis, we use that and that to create vertical axis. And then we can go ahead and just extrude-cut. So we use this option, and we use this option again. All right, but we want it to be in the correct YX axis. Okay, so that looks right. So that means we don't want what is below, we want what is on top, because that's what's inside the domain. This is what is protruding out of the domain. So what do we do? So we zoom in here, and then I'm just going to click here to represent what's inside, keeping that, and what's outside I'm going to leave off, and then we click done. Okay, the direction is pointing the wrong way. We flip it around and we do that. So if we go back to the assembly module, you see that again, that is perfectly cut out. So every of the components that we want on the extreme are all trimmed off. So what I'm going to do is to just turn off this. So I'll show no datum, show no reference point. So we have a cleaner model. But there is a problem here. So our matrix is not yet voided. So what we're going to do is a trick that I always would play. So if you go to the assembly module, so I'm going to use all these particles as a way to extrude and create gaps in the sample. So How are we going to do that? So I'm just going to deselect the matrix and then click here and say, okay, I want all particles as a single system for now. Just bear with me. So we want to create an assembly, maintain all of them, and click go on. So what do we need? So we need everything except the cuboid, and then that's done. So now we're going to cut the geometry. So this will now be the cut matrix. So let's call it a cut matrix. I'm going to use a cutting operation. I'm going to suppress the original instances, and then I'll continue. Okay, so you say, which instance do you want to cut? I select the matrix. What are you going to use to cut it? All the particles. Okay, so now we have the gaps where the particles would have been. So they are now proper particles and the gaps are there. So all we now need to do finally is to fill in those gaps with the particles. So, okay, we don't want this anymore. So all these ones that we initially, except the cuboid, I'm just going to resume them. So once you resume them, you now have a perfect arrangement where the particles are in their normal positions, exactly as they should be, and they are occupying the positions that are left by the matrix initially. And so we have everything looking right. So that when you go back onto the top here, so we can see our cut matrix is fine. The cuboids and all the systems are the way they should be, and we have a perfect assembly. So this is how you're going to trim particles that are in the boundary, and I've demonstrated this for 6 different particles of different shapes in a complicated manner, just to demonstrate how you're going to go about doing this. If you're interested in doing this for a 2D system, this is a video that will help you in doing that. Thank you for your interest in this channel, and if you like this kind of content that I'm making, please do subscribe to this channel, so when contents like this are made, you'll be the first to see it. Thank you, and see you in the next video. Bye bye.